Hello everyone and welcome to another episode of PILOTCLIMB.com. In today's video we're gonna actually calculate the takeoff performance of the Boeing 737. Okay, so today's target is actually to go through the takeoff performance and know how to calculate them. Okay, the important thing is that once you know what is the weight of the aircraft, okay, and you know that from the ramp agent that will bring you the load sheet, okay, and in the load sheet you can see what's your takeoff weight, your zero fuel weight. If you don't know what the zero fuel weight is, I made a separate video about that and I strongly recommend to watch that. Okay, so but mainly once you know the weight of your aircraft, once you know the runway characteristics, okay, the length of the runway, the upslope, downslope of the runway, and the airport elevation, once you know the weather information, okay, so the temperature, the pressure, the wind, and so on, okay, you can actually calculate how much thrust do you need, okay, for that particular takeoff. Okay, in today's video we're gonna assume that the weather is the standard weather, okay, the weather according to the ISA atmosphere. Okay, and again, if you don't know what the standard atmosphere is, I made a separate video about that. Okay, all the videos are in the link description below, so I strongly recommend to watch them if you don't know the meaning of any of these videos, okay, any of these topics. So by the way, all right, so we are on board here. We know what our takeoff weight is because we've got here, I set it in here. Okay, so in this case it's going to be zero fuel weight 55 tons, and we've got a gross weight of 62.4, so 62,400 kilograms. These are our weights. Okay, so the weather is going to be, in this case, let me put it in the hectopascal in here we go. So it's going to be a standard weather, as we said. So the QNH will be 1013 hectopascal, the temperature will be 15 degrees, and there will be calm winds, okay, no winds at all. So what we're gonna do, assuming all this data, assuming this weight and this weather, basically we're gonna try to figure it out what is our takeoff thrust that is needed. Okay, so first of all, it's extremely important to understand that on the airline jets, okay, so in this case the Boeing 737, we don't always take off with full thrust. Okay, it's not like the single engine pistons, the small Cessnas, where for every takeoff you just set full thrust and you take off. On the jet planes, the Boeings, the Airbuses and so on, we always try to minimize and set the takeoff thrust that is required for that specific weight. So what does it mean is that, let's say for example you have a super long runway, okay, and a huge runway, super long, no obstacles around. Okay, so what we don't do, we don't set full thrust in that case. We just set the minimum thrust that allow us to take off and meet the requirements for the takeoff phases. Okay, so meet the obstacle clearance and so on. Using a reduced takeoff thrust, okay, helps, has a multiple benefits. Okay, one of the biggest benefit is that what you do, you basically increase the life of the engine. Okay, because if you use the full takeoff thrust all the time, what's gonna happen is that the engine will, you will increase the wear of the engines a lot. Okay, because you're gonna have an higher AGT, thus the engine will actually suffer more for every takeoff. Okay, and in one takeoff it doesn't really make a big difference, but if you think that jet airliner, okay, can make even 10 takeoff per day, so you can imagine how much what will be the difference in the long run. Okay, another big benefit is that by reducing the takeoff thrust, you reduce the noise. So because the noise on the aviation, on the airlines, is a big deal. Okay, so by reducing the noise pollution is actually a good thing, as well as the emissions. Okay, you're gonna have less CO2 emissions. And another very big aspect about that is that by using a lower lower thrust, okay, in case of an engine failure, you're gonna have a smaller yaw moment in case you have an engine failure. Okay, especially at low speed. And that is even why when we take off from a narrow runway, okay, let's say 30 meters runways, okay, we always try to reduce the thrust as much as we can in order to have less yaw moments. So basically the nose of the aircraft going left or right depending on the engine failure. Okay, because we have a narrow runway. If you have an engine failure on a narrow runway and one engine is producing a lot of thrust and the other engine is failed, you're gonna have your nose going left or right depending on the engine failure. And since the runway is narrow, you don't want that. Okay, you want to try to limit that as much as possible. Okay, so without further ado, let's see how does it work. Okay, so we've got the FMC load up with the weights. Okay, I said the zero fuel weight is here is 55 tons and the gross weight is 62.4 tons. Again, these are data that you get from the load sheet from the wrap agent, okay? Then if you go on the next page, I said the outside air temperature, OAT, outside air temperature, is 15 degrees. And for today, we're gonna actually use flap 5 for takeoff, okay? I've been flying the 737 for more than 10 years, okay? And 99% of the time use flap 5 for takeoff, okay? You can use different flap settings. We're gonna have a quick discussion about that later, but normally it's flap 5 takeoff. Flap 5 takeoff, yeah. So then what happens is that once you know the weather, once you know the way, you move into your performance calculations, okay? In the whole days, we were actually calculating these performance using tables, okay? Piece of papers with tables, and we were going through the tables and come up with a takeoff thrust, okay? But nowadays we've got these electronic flight bags, okay, that has got the performance, the onboard performance tool that actually are just software that takes into considerations all the data that you put it in, and then you come up with a number for your takeoff thrust, okay? This is the PMDG Boeing 737 that prepares 3D, okay? But once you know how to set this one, you're gonna be able to set pretty much every OPT, every electronic flight bag, okay, onboard performance tool in this case. So if you click on performances here, what we're gonna actually, I can make it even bigger. Here we go. So what will happen in here? So as you can see, we've got, this is the performance for takeoff, okay? And now our goal for today is to fill up these all these fields in here, okay, and then come up with a number, okay? We need to have a N1, okay, a takeoff thrust set that we need for that takeoff, okay? Because depending on this weight, if you are heavier or lighter, you might need an higher or a lower takeoff thrust, okay? And as we discussed before, we try not to use full thrust every time. So the thing is, how much thrust do we need in order to perform a safe takeoff and have the less thrust possible? Okay, so the first thing that we do, we've got the airport. We select the airports in here. In this case, today we are in Lima, India, Maikeko, which is Bergamo, is the north of Italy, okay? Lima, here we go. Bravo Golf Yankee, we've got Oriel Serio, Bergamo. Runway, we've got the runway. You can select the runways. For us for today, runway 28. Then in this one is intersection. So because some airports, they have an intersection, okay, there is a taxiway that allows you to line up before the beginning of the runway, okay? If your weight is low enough, you can actually take off from that intersection, okay? In this case, we're just gonna leave the full length, okay? Now, conditions. As you can see in here, we've got, depending on the conditions of the runway, you can select them. If it's dry, if it's wet, if you have any slush, if any snow, and so on, okay? But for today's training content, we're gonna use just dry, okay? Because we are assuming that we are in ISA condition, International Standard Atmospheric Conditions. For the wind, if you have wind, you set in here the wind, okay? So the wind, for this case, we just set 0, okay? So we go there and we set 0. Okay, again, the wind, as you can see in here, it's gonna give you the headwind component. Okay, you should insert here the wind with the direction and the intensity. Okay, so in this case we've got 0 headwind and 0 crosswind components. Okay. The crosswind and the headwind tailwind component is quite important to take into consideration, because an headwind component will help you out for takeoff, and a tailwind component will make your takeoff run to be longer, okay, your takeoff distance as well to be longer, because it's pushing you, okay. So normally we have a limitations on the takeoff tailwind component, which depending on the operator, but is around 10 knots, okay. With more than 10 knots of tailwind, normally you are not allowed to take off, okay, normally. But again, depending on the operator, I know some operators, they actually they have a different limitations, but that's to give you an idea, okay. The crosswind component is very important, because depending on the crosswind, depending on the operators, depending on the procedure that you're using, you may have to apply further correction, and sometimes depending on the crosswind is captain only takeoff, okay. So that's why as well it's very important. And then every aircraft, depending on the conditions, whether it's a dry, it's a wet runway, it's a contaminated runway, we have different crosswind components, okay. There is not only one crosswind component, okay. So let's say, for example, 33 knots crosswind component is good for dry runway on the Boeing 737, for example. But when you have a medium to poor braking action, or the runway is contaminated with snow, this crosswind component is reduced, because the maneuverability of the aircraft during the takeoff roll is actually reduced, and that's that's why it's actually the crosswind component is used. So depending on your condition of the run, you should check the crosswind component and make sure that you can actually take off. Okay, then we've got the outside air temperature, and you should set that one. Okay, so in this case is 15 degrees. Again, this is very important to take into consideration because the outside air temperature plays a big role on your takeoff performances, okay? Because the higher the temperature, the lower will be the density, okay? And the lower the density, the less power, the less thrust the engine can produce, okay? So if you have a very warm day, okay, let's say 45 degrees Celsius outside, okay, you will be able to take off with less weight, okay? Your takeoff limitation will be lower because you can take off with a lower takeoff weight because the temperature is high and the density is low. It's like the same as happen when you walk on a 45 degrees Celsius summer day and you can feel that you don't have that much power. The same apply to the engines of the aircraft. Okay, the higher the temperature, the less the density, so the engine is less capable to produce a lot of thrust. Thus, you are allowed to take off with lower takeoff weight. Okay, so this is very important to understand as well. Okay, normally in an international standard atmosphere, the temperature is 15, and that's why we put 15 degrees in there. Okay. Then we've got the QNH. Again, QNH, I made a lot of video about this, okay? QNH, go on my channel and watch them. The QNH, the pressure at the mean sea level, and the standard atmosphere is 1013 hectopascal, okay? So you should set that one in there as well. Again, the temperature plays a big role with the density, and the QNH with big role with the pressure, because the lower the pressure, the less thrust you're gonna have from the engines, okay? So, for example, today is a standard day, but let's say you have a 9 or 6 hectopascal, so you've got a lot less hectopascals. So in that case, the engine will be less powerful. Fantastic. Now we can actually move on, and here it says thrust ratings. Okay, we've got 1, 2, and 3 thrust ratings. Okay, this takeoff Derate and takeoff Derate 2. These are, again, now we are talking about how much thrust do we need. Okay, so with TO takeoff in this case, okay, if you come in here, okay, as you can see on the FMC, we've got 26k, 24k, 22k, and 27k bump. To be honest with you guys, I've never used this 27k bump because this normally is a full thrust that is normally used for very short runways. Okay, the operator that I fly for, they basically, I don't even see it on the real plane. Okay, but we have 26 pound of thrust, 24,000 pound of thrust, and 22,000 pound of thrust. Okay, so as you can see, these are fixed derated. So a quick discussion about this. Okay, let's say today we are super light. Okay, so because our weight is below our maximum weight, okay, we can actually we are light, we don't need max thrust. Okay, we don't have to apply full thrust. Okay, so we can actually take off with a lower thrust setting. And again, taking off with lower thrust setting has got a multiple benefits, as we discussed already. Okay, so what we're trying to figure it out by calculating in this table here, what is our thrust setting, what is our optimum thrust setting, okay, what is our minimum thrust setting to perform that takeoff safely and meeting the requirement for the takeoff obstacles and so on. Okay, so by doing this, okay, by selecting the derated takeoff thrust, okay, we are actually telling the system, the software, I want you to calculate how much weight I can carry with the maximum takeoff thrust. I want to calculate the weight that I can carry with 24,000 pounds of thrust, and I want you to calculate the takeoff weight that I can have during the takeoff using the 22,000 pounds of thrust from the engine. Okay, so TO stands for the 26, TO1 stands for the 24, and TO2, as you can see here, is 22. Okay, so these are actually the same thing. And as you can see, if you select 26k, in this case, let's call it full thrust, has got a 98.5% of N1. Okay, so in this case, if you select 26,000 pound of thrust, okay, what we're gonna have is here on the N1 during the takeoff. As you can see in here, we're gonna have 98.5 in here. Okay, so when we set the takeoff thrust, this is gonna go all the way up to 98.5. However, if we select 24k, we've got 94.2. So as you can see, is a lot less because 26 is 98.5, 24 is 94.2. So we are talking about around 4%, and you can even say, okay, Gabriel, 4% is not that much, but again, guys, we need to think about the numbers of takeoff that we perform every day. We don't really use full thrust all the time, okay? We always try to use the minimum takeoff thrust required, okay? So in this case, we can say, okay, I want you to calculate for me the takeoff with 26, the 24 with 24k, and the takeoff with 22. As you can see, the difference here is 26 again is 98.5. If we select 24k, it's gonna be 94.2 and 1, and if you select 22k, it's 92.1. So as you can see, depending on the weight, we can actually select 22, 24, 26. If we are very light, we can actually select 22k, okay, because our weight is low enough that allow us to take off with 92.1 on N1, okay. And as you can see, we've got, how much is it, 6%? 98.5 to 92, yes, it's 6% less takeoff thrust, okay. So as you can see, when you're low, you can actually, when your weight is low, you can actually take off with a lower takeoff thrust, okay. So in this case, we can actually set the minimum and ask the software to calculate the takeoff thrust with a minimum takeoff thrust setting. So in this case, it's going to be 22k, okay. So what we are telling the software selecting TO2 is that, listen, I want you to tell me if I can take off with 22k, okay, if my weight is low enough and I can use the 22k, okay. Then we've got the ATM is a assumed temperature method, okay. The assumed temperature method is a typical Boeing thing, okay. I think the Airbus, they call it flex temp, something like that, okay. Let's put it in this way. Let's say that with 22k, okay, you can carry 60 tons of weight, for example, okay. And with 24k, you can carry 70 tons of weight. Okay, guys, this is just an example. Okay, so 22k you can carry 60 tons, and 24k you can carry 70 tons. Okay, but what happened? What happened if our takeoff weight is 65? Okay, so we have a takeoff weight that's where we cannot use 22. Okay, because 22. We could take off with 22k if our takeoff weight was 60 tons. Okay, but we don't want to use 24k because it's too much. Because if you use 24k, we're gonna have an exceeding takeoff power. Okay, but if you use 22k, we're not gonna have enough power for takeoff. Okay, so what happened is that we're gonna use 24k with a 65 tons. Okay, again, this is just an example. So we're gonna use 24k, but we want to reduce the thrust of 24k. So what we're gonna do, we're gonna actually set an assumed temperature. What we're gonna tell the system and the aircraft, we're gonna tell the aircraft and the system that we've got an outsider temperature which is higher than the real one. So if the real temperature in this case is going to be 15 degrees, okay, we're gonna tell him that maybe we have 45 degrees. Okay, so since the system of the aircraft thinks that we've got 45 degrees outside, what will happen is that it's gonna give us a less thrust, okay, a less power. So in that case, the N1 will be less, because what happened is that with a higher temperature, with a higher outsider temperature, the engine is gonna give us a less takeoff thrust because it's trying to protect the engine from an over temperature situation, okay, as well as because when the temperature is high, the density is low, and if you have less air in and you put the same amount of fuel, you're gonna have a fuel to air ratio that is not correct. So what will happen is that by using the assumed temperature method, the aircraft will actually reduce even further this fixed derate takeoff thrust. So let's say 24k with no assumed temperature is going to be, as we said, 94.2, and outside temperature 15. But let's say we say to the system that the outside temperature is 50, okay, and we put it in here. As you can see, now we've got a reduced 24k of 89.1, okay, because we said to the system, listen, outside there is not 15 degrees, we've got 50 degrees. In that case, the system, the engine, the engine is gonna give us a takeoff thrust that is lower than the 24k. So in this case, it's gonna have 24k with assumed temperature of 50 degrees, because 50 degrees is a higher temperature, and the engine is gonna give us less thrust because it's trying to protect the engine from an high AGT scenario, and on top of that, it's trying to get the correct air and fuel mixture, okay? And that's how it assumed temperature method works, okay? So when we use the assumed temperature method, okay, together with fixed Derate thrust settings, okay, the 26, 24, 22, we actually combine them, and we are trying to get the exact takeoff thrust that we need, okay? Because again, let's think about the example before. If you have a takeoff weight that is between 20, that requires a takeoff thrust that is between 22 and 24, you can reach that by using a 24K, as we said before, but with an assumed temperature, okay? And that's gonna give you the exact takeoff thrust that you need for that exact weight, okay? So in this case, we want to try to see if we can take off with 22K. The assumed temperature will leave it max if applicable, and then flap configuration. So we set flap 5, and then we have air conditioning. We're gonna have air conditioning on, okay, and the anti-ice we're gonna use anti-ice off, okay. This is again is important for takeoff performances because the air conditioning and the anti-ice, they take air from the engine. So the more engine bleed you have, okay, the less power, the less thrust the engine will be able to provide you. Okay, so if you have the air conditioning on, this will actually take air from the engine. Thus, the engine will produce less thrust. If you have the anti-ice on, this will take air from the engine. Thus, the engine will produce less thrust. Okay, so you want to tell the software, listen, I'm gonna use the air conditioning on, but I'm not gonna use the anti-ice. Okay, for example. When do you switch the air conditioning off for takeoff? When you have, for example, a short runway, you have you have to use full thrust. Okay, in this case, as we said before, let's say 26K. Okay, 26,000 pounds of thrust because the runway is super short. But you are not allowed to take off because the takeoff thrust that the engine will give you is not enough for your takeoff weight. So you can still switch off the air conditioning. In that case, by switching off the air conditioning, you're gonna have an extra amount of thrust that the engine will provide you, okay? But then you need to remember to switch it on once you take off, okay? Because otherwise above 10,000 feet you're gonna have pressurization problems, okay? So but for this example we just assume that the air conditioning is on and the anti-ice are off, okay? So now we've got, once we fill up all this field, we go to the takeoff weight, and the takeoff weight we set for us is going to be 62.2 tons, so 62,200, so 62,200 kilograms, all right? So then we click on calculate and see what it says. Here we go. So this case is saying, okay, the model of the aircraft, the model of the engine, and it's telling us we need with a flap 5 takeoff, an acceleration 8 of 3,000 feet above ground level. Doesn't have the information about the trim because we didn't put the center of gravity in there, okay? But anyway, the runway is 28, okay, takeoff gross weight 62,200 kilograms. We can use the fixed 22K, okay, the rated takeoff thrust 2, which is this one, okay. If you come in here again, this one, TO2, okay, so we can select that one, okay, with a select temperature, with assumed temperature of 33. So I take this 33 in there, okay, and I place it in there, okay. So as you can see, now we've got the information about the takeoff thrust in here. So now the aircraft knows that we're using 22K with an assumed temperature of 33. So the engines are electronically limited by this performance that we set on the FMC. Okay, so, and as you can see, we've got the N1 is 90.6. It's gonna provide us 90.6, and you can see here with this green arrow there, okay, where is the limitation, and the information is here as well. Is off by 0.1%, which is okay. Alright, and then as well in here it's gonna give us the speed V1, VR, and V2. Okay, so we can actually, if you press on takeoff in there, you can set a 137 in there. Okay, V1 137. Then we've got VR in there. As you can see, VR is 137. Okay, and then we've got the V2 143. 143. Here we go. Fantastic. So, okay, our weight is low, is 62.2 tons only, so we can take off with 22K, so a lower takeoff thrust, and on top of that we can even go further and reduce the 22K, the fixed rate takeoff thrust, even more by using the assumed temperature method of 33 degrees. Okay, in this case we're gonna have a takeoff thrust that is lower than the full 22K. Okay, the 22 pound of thrust. This is very important to do because, as you can see now, we are taking off with an N1 of 90.7 or 90.6. Okay, if you compare this N1 to the full 22k, if I come here, okay, if we select again the full 22k, all right, the full 22k is going to be 98.3. So as you can see, we've got 8% pretty much of takeoff thrust difference. And if you think about this for all the takeoffs that an aircraft does, you can really now start to understand why it is important. Okay, if you save around 8, 6, 5% of takeoff thrust for every takeoff, on the long run, it's gonna be, the company is gonna save a lot of money. The engine will have a longer life. So the company will save money because you're gonna burn less fuel for sure during the takeoff. But on top of that, the biggest cost saving there is since you're using less takeoff thrust, you are saving the life of the engine. Thus, will require less maintenance. Okay, and thus the company will save money there. All right, and on top of that, as all the benefits that you've got and discussed earlier. Okay, so now let's do another example. For example, if I came in here, okay, guys, I'm still getting familiar with this simulator. Okay, so don't. I'm trying now to change the takeoff weight. Okay, that what we're gonna do now, instead of having a zero fuel weight of 55 tons, I'm gonna increase the zero fuel weight. Okay, let's put. I'm gonna put 62 tons on the zero fuel weight, or 60 tons. Okay, zero fuel weight of 60 tons, which is quite high. Okay, so now we've got 60 tons on the zero fuel weight. Okay, if I click, here we go. So now zero fuel weight 60 tons, takeoff weight 67.1, so 67,100 kilograms. Now, all the conditions are the same. Okay, the runway, the wind, the temperature, and so on. What I have to do, I have to change the takeoff weight here and see if I can still take off with 22k with an assumed temperature. So if I select there and I show and I write down 67, sorry, here we go. So 67,100 kilograms in there, okay, and I click calculate. Let's see what it says. Here we go. So it says no valid assumed temperature found for present conditions. That means that the assumed temperature method is not available because we minimum need 22k. Okay, so if I click in here, now you can see that it's saying, okay, with a 22k, okay, TO2, which is this one, TO2 in there, okay, is saying that we need a full 22k with no assumed temperature. So in here before there was the assumed temperature, but because now our weight is higher, okay, we cannot use any assumed temperature above the 15 degrees that we set, or 14 degrees now, okay. So what happened is that now we can only take off with full 22. So we go full 22 in there, and we've got in here 91.9 and we've got 92.1. Yeah, there is a small difference, probably it's because of the temperature. Because as you can see here, we've got 15 degrees and here is 14 degrees. Let me try to change this. Here we go. So 15 degrees, 92.1, 92.1. So now, as you can see, because our weight is higher, we cannot use the assumed temperature method. Okay, we can only use the fixed Derate takeoff thrust of 22k. Okay, so let's change it again. So for example, if I change again the weight of the aircraft and make it heavier, okay, let's put 72. This is quite a big zero fuel weight. Okay, so 62 zero. Okay, now our zero fuel weight is 62 tons. Okay, I click in here. Here we go. So now 62 tons in there and 69.1 our takeoff, our gross weight. Okay, if I come here, here we go, and I set now 69,000 and oops, should work 69.1. Let me see what it says. So now says calculation error message, no takeoff allowed. Planned weight exceed maximum allowed weight of 67,308 kilograms. Alright, so what is telling us, okay, is that if we use the fixed rate of 22k, we cannot take off with that weight, because the 22k, okay, the takeoff thrust that will be produced by the engine at 22,000 pounds of thrust will not be enough to take off with 69.1 tons of weight. So what we can do, guess what? We can come here and say, okay, fantastic. Let's see if we can take off with the next one, with the 24k. Okay, TO1 24k. So let's say if with 24,000 pounds of thrust, we can actually take off. I select calculate again, and now we've got the information, because it's saying the system now, the software is telling us that now with 24k we can actually take off. Okay, so let's say again, flap 5, acceleration 3000, the speeds are here, running to 8, takeoff weight 69.1. We've got at 24k, because TO1, it says TO1 is 24k, okay, and we can actually even use a reduced, an assumed temperature method of 31 degrees. So I can select in there 31 degrees. Here we go. And now we've got 93.4 and 93.4 in there. So as you can see now, the 22k was not enough, however 24k was too much. So what the system said, okay, 22k is not enough, 24k is more than you required. However, if you use 24k with a higher assumed temperature, you can use the exact takeoff thrust that you need for that weight. Okay, so in this case we're actually doing an optimized takeoff, because we're not using any thrust that we don't need. Okay, because if you use full thrust every time, you're wasting the engine's life and so on. Okay, so guys, I hope you enjoyed this video about takeoff performances, and now I make a bit clear for you how to calculate this takeoff performance. Again, I'm gonna link in the description below the video regarding the international standard atmosphere and the zero fuel weight, okay? And as well as I'm gonna link in the description below what is the effect of the density, altitude, and pressure altitude. Basically, how does the pressure and the temperature affect your takeoff performance and the performances of the aircraft in general, okay? So if you have any question, leave in a comment below and I will help you out. Also go to pilotclimb.com, where you can subscribe for free pilot training content. I wish you a great day, and I'll see you on the next one.